this problem, we just have to draw a curved arrow for each step, and then we have to explain something about the stereochemistry that arises by forming this product. So let's tackle the first part by drawing the curved arrow. So let's compare it. From the left to right, I only see the difference on that hydroxide becoming the negative charge on that oxygen. And then I introduced the lithium hydroxide. Now remember that lithium hydroxide is one of the very strong base. So assuming this happens in water, well, in most cases we have the water as our solvent. Let's just make these two hydroxide because it's strongly dissociated in the solvent. So I'm gonna have the minus charge there, and that's gonna cause a proton transfer by cleaving off that hydrogen, or by grabbing that hydrogen, and then the electron between this that forms this bond will now be placed on the oxygen atom. Thus we have a negative charge on the oxygen. And from this structure to the third structure, I see a big change because you see the minus charge on the bottom, but now I have the minus charge on the very top. And also I form another ring structure between this oxygen and the carbon over here. So there will be another bond over between that. And also you're gonna notice our pi bond structure in the ring are actually altered. So you see that pi bond over there, but now we only have a pi bond there. And same thing happened to the very top pi bond. So there is a major change going on the left side structure, but on the right side I see no change in these three rings. So same, the chirality of this carbon is still preserved, and no change in the pi bonds of this phenyl group or benzene ring here. So I'm gonna draw for a guide, as a guide, I'm gonna draw the lone pairs around that oxygen. And since I no longer have the negative charge on the very bottom oxygen, I'm gonna put the arrow that creates the lone pair creates our double bond, and then in turn that's gonna push our pi bond in series. And this pi bond over here is gonna act as the nucleophilic center. Okay, remember there were three kinds: lone pair, and another was the induction, and another was this is the third one, the double bond. So our pi bond is gonna form a bond with that oxygen, and in turn that's gonna push the double bond to form a double bond next to it, and then it's gonna have this domino effect until we get the negative charge on that very top oxygen. Okay, so we have a bunch of arrows that creates the third structure, third compound here. Okay, other than that, so we form a bond, so we have it here. So from here to the last final product, I'm gonna also draw the lone pair around just in case, and also the lone pair on the top. And now notice that we have a hydrogen attached to the negative charge, so that's gonna grab that hydrogen from the water. And then don't forget the second arrow that actually placed the bonding electron toward the oxygen. So if I label this, I'm gonna say this is a proton transfer in the first step. And in the second step, I have the nucleophilic attack from the lone pair at the bottom. And for our final step, we have the proton transfer again. So this answers our part A. Now to answer the part B, it said include an explanation for the observed stereochemistry. The first carbon you saw that bears the stereochemistry is not changed throughout the reaction. However, you're gonna notice that we formed the stereochemistry on this specific carbon over here, if you see the bottom. So we have the thing that pops up, and then in other words we have the wedge that pops up, and then we have a dash that creates it. So why do we have this specific perspective, or why do we have specific stereochemistry on the carbon? That's because of this wedge you see here. If you go back to the first and second compound, or first and second structure, you will see that there is a wedge shape that actually pops up that oxygen, and then you will also see the dash on that oxygen. So if you're kind of visual person, you will see that this part of the ring, let me use a different color, this part of the ring go below our page. If we imagine the top two rings to be on the page, or embedded in the page, this in a way has to go below or maybe on the page, but most likely to go below the page. And that, since the oxygen, the left oxygen actually pops up, and rings are not really flexible, so they have to be popping up. So this has to go toward us. In other words, okay, this is probably a better picture. This has to go up. So in other words, it has to go towards us, and this ring probably have to go below us, or below the page. Below the page. Okay, so if this pops up and this is still on the page, then we have no choice but to draw the dashed line that forms a bond between the oxygen and carbon. Another way to think is, you know that the carbon has to be sp3, right? It's attached to 4 different groups. That's why we have the chiral center over there. And based on a lot of structure we drew in the previous chapters, when you have a wedge and the dash shape, that really makes the bond angle among each other like 109.5 degrees. And imagine this is also popping up, that dashed line, then it's not really likely to create the 109.5, and thus that creates the angle strain. So if you have two bonds that's embedded on the page, the fourth bond has to be on dash. Now if you still have hard time seeing that, now I can actually tilt the first compound, the very first structure, like this way. Okay, I tilted it, and this is still on the page, and then I'm gonna have the double bond top and bottom. Okay, top and bottom, and then now this will be on the top, and you have to be careful. Okay, we're looking this as a bottom, and on the right side will be here. So on our right side, I'm gonna have the oxygen that pops toward us, and then we're gonna have the oxygen, another oxygen that's actually going below the page or away from us. And we're gonna have a ring structure here, and I'm gonna draw in perspective so that you see that this is popping up toward us. Okay. And then you're gonna see this also pops up even more toward us. And then our hydroxide has to be attached to this, so the ring that comes toward us. If you see this, this is on the page and this is like, popping toward us. We have no other ways to create this bond that has to go below from that perspective. So what I mean is we have to have the dashed line. Now imagine we put the wedge instead, then you're not really forming, okay, you're not really forming the bond. I mean, if it's popping up together, it's attached to nowhere. Therefore, we have no other ways to create this specific stereo chiral center with a dashed line and the wedge shape, and this conform with it. And or that's because of, or this happens because of that wedge shape on that specific carbon, oxygen, that makes it in perspective. Alright, that's it. Thanks for watching.